Good morning, class.
Good morning, sir.
I hope everyone is fine. All are doing good.
Yes, sir.
All right, very good. So, last class we were discussing about measure of dispersion, and we had done till coefficient of variation, right? So today we are going to discuss about graphs first. Okay, so before we start talking about graphs, you guys have to tell me why do you think graphs are important? So what additional information you get when you draw a graph?
Sir, can I answer?
Yes, please.
So a graph is basically a visual representation of the data and the results.
Mhm.
So for anyone who needs to immediately understand the data set and understand the results, a
Mhm.
graph allows them to quickly just get like a gist or a summary of the data set. So that
Very
is
good,
what
very
graph
good.
is used for.
Yes. So, yes, guys, others. No one knows anything about graphs. This is very strange. Adhish.
So, so can
Yes.
I?
Yes, yes, please go ahead.
Graphs are basically the visual analysis of the data to get
Mm-hmm.
a quick review of the results.
All right. Very good. So what all we can achieve using graphs? Yes, Nehal.
Sir, am I audible? Hello? Sir, am I audible?
Yes, Nehal, you can tell.
Yes. So, sir,
Yes,
graph is
you're
basically
audible now.
what, sir?
You are audible.
Okay, sir. So, sir, graph is a diagram that show the relation between
Sir, you can go ahead. Yeah, go ahead,
the
go ahead.
variable quantities or the comparison between the two variables.
Right, very good. So you can basically establish relationship. You can come do the comparison. All right. So so easy to interpret the data. So graphs basically we use for data interpretation, for establishing the relationship, to compare different groups, or we can use graphs for making predictions, right? So based on the trend with that we see in graph, we can make prediction. And what more we can do with the graph? Yes, Ishita.
So, so basically, with the help of graphs, we can also analyze a large amount of data in a small diagram. comparison of data of different months, like different months or different years.
Such errors are pretty easy. So let us assume you are working with the say kids, okay, and you are recording their age and certain behavior, and the sample that you are having are in the age group of say between 2 and 12. Okay, so you are entering their ages and certain behaviors for each of the kids in your study. So what if by mistake you entered 66? So age 6 for some particular kid, you entered 66. If you have a large amount of data, so just by bare eyes, it may not be possible for you to catch that 66 in your data set. But when you
Your voice is
graph,
breaking.
immediately you can see that there is one particular point. Okay, is it better now?
Yes, sir.
Okay. So I was telling, along with all these applications that you guys have told, you can also use graphs for catching errors. Okay. Okay. So let me first see your syllabus. What all type of graphs you are supposed to study. So we'll discuss something about those graphs only. Okay, so you have bar chart, pie chart, box plot, histogram, ogive, and scatter plot. So I guess we need to open another application to understand the graphs. I'm sure all of you have heard or used these graphs sometimes.
Yes,
So
sir.
any graph which is new for you guys, I guess ogive may be new for you, right? So bar chart, histogram, all of you know about it. Anyone who does not know what is bar graph or histogram, raise your hands. Okay. So let me make graphs. So we have these two types of graphs. So who will tell me which one is bar graph, which one is histogram? What are
The
the
A is
differences
bar
between
graph.
these two?
A
Yes,
is
A
bar
is
graph and B is histogram. B is histogram.
okay. So A is bar graph and B is histogram. All right. So who will tell me what is the difference between two and why in this particular graph, in bar graph, you see distance between different bars, and in histogram there is no distance, so they are touching each other. So what is the logic behind having two different types of graphs? So you see, the only difference that I can see between these two is in one graph, in bar graph, I have distance between two bars, and in histogram, there is no distance. So that is telling something. Yes, Yukta.
Yes, sir. So in bar graph basically can represent a group data where we see the length of bar is proportional to the measure of data, and in histogram it is used for representation of continuous data in a data set. So
All
that's
right.
why there is no gap in between.
Okay, very good. So bar graph and histogram, what happens? Bar graph we use basically to represent different variables. So they may be different variables, or they may be same variable in different groups. Okay, like I can represent height, weight, blood pressure, vitamin B12 level, everything in same graph. Okay, now depending on what values I'm seeing, proportionally I can make the height of that particular bar. Okay, so why we have gaps here? Because the way we show different variables, so they have nothing in common. So suppose this bar is for weight and this one is for height. Okay, since they are entirely two different variables, so they are not touching each other. So this is used basically for um, different groups. Okay, while in histogram we try to represent only one variable at a time. Okay, so here we have many variables. Okay, so you have multiple variables in bar graph, while in histogram we have only one variable that we show in different groups. So what we do, we basically classify our data into different groups and then show one variable in all these groups. So let us take the example of, say, income. So if we want to show the income of different age groups, so like the first bar is for age group, say 15 to 20, this is 20 to 25, 25 to 30, 30 to 35, like that. So this entire data is about income, but in different age groups. Since it is the same data, so all the bars are representing income. So that is why we can touch these bars together. So that's the basic difference. So histogram we basically use for continuous variable, and the bar graph you can use both for continuous and categorical. Okay, so if you are showing the number of males or number of females, okay, so you can show proportion or percentage or absolute number. Understood, guys? What is bar graph? What
Yes,
is
sir.
histogram? Okay, then the next type is pie chart. So pie chart is basically when you want to show uh, proportions. Okay, and it is in the shape of a pie. Okay, so let us assume I want to know how many of you are going to the campus by own car, how many of you are taking cab, how many of you are taking public transport, how many of you are walking, okay, and how many of you are staying in the hostel. So accordingly, I can divide my this pie into different groups. So let us assume this is 35% who are taking public transport, 35% are staying in hostel, 25% are uh, they coming by their own vehicle, and rest are walking. So this should be a bit less, 10%. Okay, so like that you can show the pie chart. So pie chart is again used for different categories, and you show proportions. So the size of the pie is proportional to the percentage or proportion of the data. Then the next is box plot. I think I've shown you guys box plot while discussing interquartile range. आपको बॉक्स प्लॉट मैंने आई गेस समझा दिया था ना?
नो सर।
नहीं, बॉक्स प्लॉट नहीं हुआ आपका?
नो सर।
अच्छा ठीक है, चलो बॉक्स प्लॉट में एक्सप्लेन कर देता हूँ देन. I hope all of you remember median and interquartile range, right? तो हमने मीडियन किया था, interquartile range in measure of dispersion, and हमने upper fans and lower fans ये सब बताया था मैंने आपको, right?
Yes, sir.
You guys remember? ठीक है.
Yes.
So using these values, we can make a certain type of graph that is called as box plot or box and whisker. Whisker आपको पता है ये क्या होता है? तो whisker जो dogs और cat के जो बड़े बड़े हेयर होते हैं उनके फेस पे, so that is called as whisker, which is used for वो क्या यूज होता है उसका whisker का? Anyone? क्या काम आते हैं वो डॉग्स के और कैट्स के? जो बड़े बाल होते हैं उनके फेस पे, एनीवन हु विल टेल मी? शक्ति?
Sir, I don't know.
You don't know? That is really very strange. बायोलॉजी के स्टूडेंट्स को ये चीज नहीं पता है. तन्वी?
Sir, can you please repeat the question?
The question is the long hair that you see on the face of cat or dog, we call them as whiskers. What is the use of that? एनिमल के क्या काम आता है वो whisker?
So they work as a sensory.
Yes, they work as sensory organs, है ना? तो आप वो जो लॉन्ग हेयर होगा उससे वो सेंस करता है टेम्परेचर. तो आप उसको बहुत गर्म दूध दे दोगे या बहुत ठंडा दूध दे दोगे तो वो क्योंकि उसका उसमें मुंह लगने से पहले उसके हेयर जाएंगे तो उससे वो सेंस करता है टेम्परेचर को. ओके, सो दोज आर कॉल्ड एज विस्कर. सो बॉक्स एंड विस्कर प्लॉट में भी हम लोगों के पास विस्कर होता है. तो विस्कर भी एक तरह से यहाँ पे सेंसरी ऑर्गन के जैसे काम करता है. तो आई विल शो यू बॉक्स एंड विस्कर प्लॉट कैसा दिखता है. So if you see box and whisker, I don't know whether you guys have seen such plot. So this is called as box and whisker. तो ये तो बीच में box हो गया है. Let me use some other color. So you see, so this is my box और जो ऊपर में और नीचे में लाइन है, those are called as whiskers. So any data point, so suppose this is my scale here. So let us assume I am measuring vitamin B12 levels. Okay. So ये box के बीच में there is one line, right? So this line is basically my median. So अगर हमें median interquartile range upper lower fans को show करना है, that we do through box and whisker plot. So this line in the middle of the box is my median. This is my third quartile and this is my first quartile. So this box basically is your interquartile range. So जो middle 50% data है that we represent through this box. और ये जो नीचे line है और ऊपर है, these are my fences. So this is my upper fence and this is my lower fence. So for my data, when I calculate median interquartile range, upper fence, lower fence, then I can represent my data in such type of graph. This is called as box and whisker plot. So any value that you see outside these fences, तो सपोज आपने जो डेटा कलेक्ट किया है उसमें कुछ डेटा पॉइंट्स है विच आर above and below these fences. So all these data points are considered as outliers. Clear, guys?
Yes, sir.
Okay. Then the next type of plot is OGIV. चलो OGIV से पहले स्कैटर प्लॉट जो सब जानते हैं वो वाला कर लेते हैं. तो स्कैटर प्लॉट भी आई एम श्योर आप सब ने देखा होगा. I'll show you scatter plot. So if you have to, so scatter plot is basically used for continuous data, and scatter plot is used to establish relationship. तो दो वेरिएबल्स के बीच में कुछ रिलेशनशिप है क्या? So suppose this is the data on, तो आपने कुछ लोगों का let us assume कुछ सैंपल्स आपने लिए, अपना क्लासमेट्स का ही सैंपल ले लिया, एंड व्हाट यू हैव डन, यू हैव calculated their height and their weight. So let us assume on x axis we have height, on y axis we have weight. We want to know whether height and weight has something to do with each other. कोई relationship है क्या? So if you want to establish a relationship between two continuous variables, so the easiest way is to draw scatter plot. So scatter plot क्यों बोलते हैं इसमें? जो भी points है they are scattered all around. ठीक है, depending on their values. So like each data point is one sample. So ये एक जो data point है, this is one sample. तो ये person का यहाँ पे height है और इधर में weight है. Similarly, if you consider this data point, तो ये इसका height है और ये इसका weight है, right? So you draw this plot, and through this plot you can see if there is some pattern. तो अभी ये वाला डायग्राम से मुझे लग रहा है कुछ कुछ इस डायरेक्शन में मेरा रिलेशनशिप जा रहा है. सो इट कैन बी इन दिस डायरेक्शन, इट कैन बी इन दिस डायरेक्शन, राइट? दैट डजंट मैटर. इस डायरेक्शन में जा रहा है मतलब एक के इंक्रीज होने से दूसरा भी इंक्रीज कर रहा है, और इस डायरेक्शन में जा रहा है तो एक का डिक्रीज करने से दूसरा भी डिक्रीज कर रहा है. सो दैट इज सेम, राइट? So if you see some kind of pattern, you can establish whether there is any relationship between the two or not. और अगर आपको यही ग्राफ कुछ कुछ ऐसा दिखाई दे, the points are scattered all around, then you cannot say कि भाई कुछ रिलेशनशिप है. अभी ये तो पूरा कोई पैटर्न शो नहीं हो रहा है ना. All the points are scattered all around. So that means there is no relationship. So such type of graphs are called as scatter plot. So scatter plot हम लोग basically use करते हैं for establishing the relationship. Okay. Now the next type of graph is OGIV. OGIV भी आप लोगों ने सबने किया होगा. You just आपने टर्म शायद नहीं सुना होगा. So OGIV में क्या होता है बेसिकली? We make cumulative frequency. एक तो होता है frequency. So suppose मैंने चेक किया है कि भाई so let us assume I have calculated कि किसी फैमिली में कितने बच्चे हैं. So मैंने काउंट किया. तो सपोज 10 फैमिलीज में एक बच्चा है, 12 फैमिली में 2 बच्चे हैं, 15 फैमिली में 3 बच्चे हैं, ठीक है, 7 फैमिली में 4 बच्चे हैं, ओके, 3 फैमिली में 5 बच्चे हैं, और एक फैमिली में एक बच्चा है, सॉरी 6 बच्चे हैं, ठीक है. So what you can do, you can calculate the total number of kids and total number of families, right? Then what you can do, you can calculate the frequency. तो ये जो टोटल नंबर ऑफ फैमिलीज आपकी कितनी होगी, 15 and 20, 12, 27, 37, 44 एंड 48. तो टोटल 48 फैमिलीज का डेटा है. So then what you can do, you can convert these values, these absolute numbers into percentage. तो 48 का 10 is कितना परसेंट, तो आप वो परसेंटेज कैलकुलेट कर सकते हो. ठीक है कि कितना परसेंट फैमिलीज में एक किड है, कितना में 2, 3, 4 लाइक दैट. यू कैन प्लॉट दैट डेटा हियर. सो सपोज एक किड के लिए इतना फैमिली है, यू कैन मेक अ हिस्टोग्राम. तो 2 किड के लिए इतना है, 3 किड के लिए इतना है, राइट. तो 4 इतना फैमिलीज में है, ये 5 का है, ये 6 का है, ऐसा. सो दिस इज योर हिस्टोग्राम. So what is O give? O give में basically you add values together. So ये let us assume ये हमारा है 15%. Next is 20%. उसके next is 30%. फिर आपका आ गया let us assume again 20%. Let us assume, ठीक है. So cumulative histogram में क्या करते हो? So first bar that you make is for 15%. Next bar is you combine these two, 35%. Next bar is 15 plus 20 plus 30, ऐसा करके. So what you are doing, you are cumulative the next data point with the previous ones. तो ऐसा करके एक आप जो ग्राफ बनाते हो, so that is called as cumulative frequency graph और O-give. तो इसी को हम लोग O-give बोलते हैं. तो इसको दो तरह से आप रिप्रेजेंट कर सकते हो. इधर यू कैन मेक दिस बार्स और यू कैन जस्ट सिंपली डॉट्स लगा सकते हो. जैसे ये इसको यहाँ पे मैं एक अलग कलर यूज कर लेता हूँ. तो इसके लिए एक डॉट होगा, ऐसा एक इसके लिए एक डॉट होगा, डॉट डॉट डॉट, फिर ऐसे जो भी नीचे आता जाएगा. तो सच ये नीचे नहीं आएगा, सॉरी, कभी भी तो इंक्रीज ही होता जाएगा क्योंकि ये क्यूमुलेटिव है ना, तो ऐड होता जाएगा इसमें. तो इस तरह का ग्राफ को हम लोग बोलते हैं ओ गिव और क्यूमुलेटिव फ्रीक्वेंसी. तो ये बार का शेप में हो गया, ये लाइन ग्राफ हो गया है. बोथ आर सेम. तो इसमें हमने जस्ट लाइन को शो किया है. तो दिस इज कॉल्ड एज ओ गिव और क्यूमुलेटिव फ्रीक्वेंसी. तो यही सब टाइप का ग्राफ्स है आपका सिलेबस में. These are very basic graphs, so I would suggest read more about it. Okay, and if you face any difficulty, if you are not able to understand anything, let me know. So any doubts, any questions so far? Anyone? Yes, Yukta, you have some question?
Yes, sir. I want.
हाँ बोलो.
Sir, can you explain upper fence and lower fence?
अच्छा ठीक है. So this is my box and whisker plot. Okay. तो बॉक्स एंड विस्कर प्लॉट हम जनरली यूज करते हैं व्हेन वी हैव सम एक्सट्रीम वैल्यूज इन आवर डेटा सेट. ठीक है. सो व्हेन वी आर नॉट एबल टू, सो व्हेन मीन इज नॉट एक्चुअली गिविंग अस द सेंट्रल पोजीशन. ठीक है. सो दैट टाइम वी गो फॉर बॉक्स एंड विस्कर प्लॉट. तो बॉक्स एंड विस्कर प्लॉट में दिस इज माय Q3 and this is my Q1 and here I have Q2 or my median. So from Q1 to Q3 is my interquartile range. So let us assume this distance between these two is say 20. Okay. चलो मैं इसको स्केलिंग कर देता हूँ यहाँ पे. let us assume this is 10, अच्छा ये 20 है. So हम लोग क्या करते हैं, इसको 10 नहीं लेते हैं. So the distance between Q1 and Q3 is 20. ठीक है. So how do you know what is my lower fence and what is my upper fence? ठीक है. Because any data point outside these fences is considered as outlier or abnormal value. So in order to calculate this these fences, so let us assume we have to calculate lower fence. तो उसके लिए मैंने आपको बताया होगा, we have to use the formula. So 20 into 1.5. So 1.5 times of IQR, that is 30. So subtract this 30 from Q1, क्योंकि स्केल नीचे जा रहा है ना यहाँ पे, तो Q1 से तो नीचे, अगर नीचे का देखना है तो Q1 से हमें सब्सट्रैक्ट करना होगा 30 को. So let us assume this Q1 is say 70, यहाँ पे आपका 70 आता है, and Q3 is 90 because difference 20 का है ना. So 1.5 times IQR is 30. So 70 पे अगर आपका Q1 है, 70 minus 30 is 40. So this number is 40. So at 40 you have something called as lower fence. तो अगर आपका डेटा सेट में कोई भी नंबर है which is below 40, even if it is 39.5, so that is considered as outlier. Similarly upper fence में जाओगे, so Q3 के ऊपर जा रहा है, so Q3 में आपको ये ऐड कर देना है. तो लोअर फेंस के लिए Q1 से सब्ट्रैक्ट करना है और अपर फेंस के लिए Q3 में ऐड कर देना है. तो 90 plus 30, 120. So this is your upper fence. Any number which is above 120 or below 40 is considered as outlier. So these are called as fences. So ये fence जो है ये बताएगा आपको कौन से नंबर आर विद इन नॉर्मल रेंज एंड कौन से नंबर आर आउटसाइड द नॉर्मल रेंज. क्लियर?
Yes, sir. Thank you, sir.
Okay. So any more questions? Anyone else? Yes, guys, you can ask questions. No questions.
Sorry.
Again?
सर ये 120 कैसे आएगा अपर
You-
फेंस?
All right. So मैंने बोला ना this Q3 is 90. Right. So upper fence के लिए the formula is Q3 plus 1.5 times IQR. तो 1.5 times IQR क्या है? 30. IQR is 20. 1.5 into 20 is 30. तो Q3 में आप ऐड कर दोगे 90 plus 30. और लोअर फेंस के लिए क्या है? Q1 minus 1.5 times IQR. So Q1 minus 1.5 times IQR. Now this 1.5 times IQR is 30. Q1 is 70. So 70 minus 30 is 40. So 40 is my lower fence and 120 is my upper fence.
ओके सर.
All right, guys. So any doubts, any questions? Okay. Chalo, I'll do one thing. I'll show you a small video also, उसमें आपको और अच्छे से clear हो जाएगा box and whisker plot. चलो, let me play this video for you guys.
In this video, we will be looking at the 5-number summary, box plots, and outliers. The 5-number summary gives us a way to describe a distribution using only 5 numbers. These 5 numbers include the minimum, first quartile, median, third quartile, and the maximum. So if we took a sample and measured some random quantitative variable, we could order these values from smallest to largest and use the 5-number summary to describe the distribution. The minimum is the smallest value in a dataset, and the maximum is the largest value in a dataset. The median is the middle data value. It is a point at which 50% of the data values are below the median, and 50% of the data values are larger than the median. Now, the median of the bottom half is called the first quartile. It is a position where 25% of the data values are below it, and 75% of the data values are larger than it. The first quartile is essentially the median of the median. The same thing can be said for the third quartile. The median of the top half gives us the third quartile, and it is a position where 75% of the data values are below it, and 25% of the data values are larger than it. The 5-number summary also gives us a way to divide the data into 4 equal quarters. So let's determine the 5-number summary for the following dataset. We'll start with the median. To find the median, you can look for it visually, and you should find that the median is equal to 33. You can also use the formula to find the position of the median, and we find that it is in the 8th position, which is equal to 33. Now to find the first quartile, we can use the same formula to find the position of Q1, except this time n refers to the number of data values below the median. There are 7 data points below the median, so n is equal to 7, and we find that the first quartile is in the 4th position. So we count to the 4th position and we see that Q1 is equal to 25. To find the third quartile, we will do the same sort of thing, except n refers to the number of data values that are above the median. There will always be symmetry, so you should find that Q3 is also in position 4. So we count 4 positions above the median, and we find that Q3 is equal to 36. Now the minimum is the smallest number, and the maximum is the largest number. So as a result, this is our 5-number summary. We can then take these 5 numbers and make something called a box plot. A box plot gives us a visual representation of the 5-number summary, and it looks something like this. Each vertical line on the box plot represents a number from the 5-number summary. The horizontal line that extends out from the box are called whiskers, and the actual box itself is called the interquartile range. The interquartile range refers to the middle 50% of an ordered dataset, and it is equal to the third quartile minus the first quartile. We can also have something called a modified box plot. It's like a regular box plot, except it accounts for outliers. Sometimes, outliers in a dataset aren't that obvious. However, we can mathematically check if a dataset has outliers in it. We say that a data value is considered to be an outlier if the data value is less than Q1 minus 1.5 times the IQR, or if the data value is greater than Q3 plus 1.5 times the IQR. So if you remember the following dataset, we had calculated the 5-number summary to be 10, 25, 33, 36, and 59. To check for outliers, we first need to calculate the interquartile range. We found that Q3 is equal to 36, and we found that Q1 is equal to 25. When we simplify this, we get an answer of 11. Now we said that a data value is an outlier if it is less than Q1 minus 1.5 times the IQR, or if it is greater than Q3 plus 1.5 times the IQR. At this point, we can start substituting values. Q1 is 25, Q3 is 36, and the IQR is 11. And so we say that a data value is considered to be an outlier if it is less than 8.5 or if it is greater than 52.5. If we look at our dataset, we see that no values are less than 8.5. However, we do have a value that is greater than 52.5. Therefore, we say that 59 is an outlier. And so when we make a modified box plot, we write the outlier as a dot, and the whisker will only extend to the new maximum. In this case, it is 50. So to quickly recap, a regular box plot is drawn using the 5-number summary. A modified box plot also uses the 5-number summary, but it accounts for outliers. And if there are outliers, a whisker or both whiskers will extend only to the new minimum or maximum. Similar to back-to-back stem plots, we can have side-by-side box plots. By having them side by side, we can make easy mathematical and visual comparisons between two sets of data.
All right, guys, I hope it is clear to you. What is the use of box plot? How do we make it? So any doubts, any questions, anyone?
No, sir.
Okay. So that is all about graphs that we had discussed today. So with this, we are done with our first module. Okay. Now the second module we have correlation and regression. Third module we have probability. And fourth module we have sampling. So we'll start with the fourth module first, because once you learn fourth module, then it will be easy for you to understand module number 2. Okay, so in the next class we'll be starting with fourth module, and in the fourth module we have sampling types and data sampling distribution. So we'll first start with sampling distribution, then we'll come back to sampling type. Okay, so my suggestion is all of you read whenever you get time, read about sampling distribution. So in the sampling distribution we have binomial distribution, Poisson distribution and normal distribution. So what we are going to study? So we studied different type of variables, basically two types, qualitative and quantitative, right? Now how these variables are distributed in the population. तो अगर आप कोई क्वांटिटेटिव वेरिएबल को स्टडी करते हो इन द पॉपुलेशन, वो कैसे डिस्ट्रीब्यूटेड है. सो यू कैन टेक एनी बायोलॉजिकल वेरिएबल. तो आपके अगर आप चेक करना चाहोगे ब्लड शुगर लेवल पॉपुलेशन में किस तरह से डिस्ट्रीब्यूटेड होगा, या कोई भी वेरिएबल, विटामिन B12 लेवल या हाइट और any quantitative or qualitative variable, any biological variable, how they are distributed. And once you know the distribution, you can make certain decisions. ठीक है. So अगर आपको कोई ड्राइव करना है सपोज फॉर पब्लिक हेल्थ, कि भाई लोग अवेयर हों सपोज फॉर डायबिटीज, तो आपने कैंप यू आर प्लानिंग टू मेक अ कैंप. ठीक है, कि मुझे लोगों को ब्लड शुगर लेवल चेक करके उनके बारे में बताना है. सो यू हैव टू फर्स्ट डू सम कैलकुलेशंस कि भाई मैं कितने लोगों का ब्लड टेस्ट करूंगा, कितनों को मैं एक्सपेक्ट कर रहा हूँ कि उनका शुगर लेवल ज़्यादा आएगा, फिर उनको मैं कुछ सजेस्ट करूंगा, डू दीज मेजर्स सो दैट यू कैन कंट्रोल योर शुगर लेवल. सो आप एनालिसिस करते हो ना, प्रॉफिट एनालिसिस. सो आपका कितना कॉस्ट लगेगा, कितना लोगों को आप कैप्चर कर पाओगे जो डायबिटिक हैं. सो पता लगा आपने 1000 सैंपल्स को अगर आपने स्क्रीन किया है, सो इन दी एंड आपको सिर्फ 3 या 4 ही लोग मिले जिनको डायबिटीज था, अगर उसका इतना कम प्रेवलेंस है डिजीज का. तो ये सब एक्सरसाइज आपका फ्यूटाइल होगा. सो यू आर नॉट एबल टू कैप्चर दैट मेनी पेशेंट्स. ठीक है ना. सो दैट थिंग यू कम टू नो कि अभी कोई डिजीज का कितना पेशेंट हो सकता है, वो सब डिस्ट्रीब्यूशन दैट यू कम टू नो थ्रू सैम्पलिंग डिस्ट्रीब्यूशन. तो अगला क्लास में विल स्टार्ट विद सैम्पलिंग डिस्ट्रीब्यूशन. ठीक है. So any doubts, any questions so far? Okay, if no doubt, then
No,
thank
sir.
you very much, guys. Bye bye. Have a nice day ahead.
Thank you, sir.
Thank you, sir.